Hello friends, in today's question, a tube of length L is completely filled with an incompressible liquid of mass m and closed at both ends. The tube is then rotated in a horizontal plane about one of its ends with a uniform angular velocity omega. The force exerted by the liquid at the other end is. So we are given that there is a tube whose length is given as L and it is filled with incompressible liquid and is rotated about one of its end with a angular velocity of omega. So we are supposed to find out the force exerted by the liquid at the other end. So in this it is given that the liquid is incompressible. So we can treat that this rod is, you can say this tube can be treated as now as a uniform rod, and entire calculation can be based on now the same thing which we are going to use for the uniform rod. So you can say liquid is incompressible therefore it can be treated as a uniform rod. So we can calculate the amount of force based on the center of mass. Thus, the calculation can be done using center of mass. So if the length is, entire length is L, so let us suppose this is the center of mass. So the length of center of mass will be equal to L by 2. So the centrifugal force that will be acting force, let us suppose given as Fc, will be equal to m omega square r. Now it will be rotating with the radius, so this is our center of mass, so it will be rotating something like this of a circle whose radius is L by 2. So we get this is our center of mass and it will be now rotating along this axis and the radius is our L by 2 and this is a mass. So substituting R is equal to L by 2. So from here we can say that R is equal to L by 2. Therefore the force Fc will be equal to half m omega square L. Now the same question can be solved by considering a small element dx. So let us try that also. This is second approach. Considering a small element dx. Considering small element dx. So let us draw it again. So let us consider this element at dx, which is at a distance of x from the axis of rotation. Total mass is given as m and length is capital L. So therefore we can say the mass of the small element dx will be equal to mass per unit length multiplied by dx. You can say therefore dm will be equal to m divided by L multiplied by dx. So force because of this small element dx force due to dm, we can write that df will be equal to dm omega square x, and dm we already know is given as m by L, so we substitute it here, we get m by L omega square and x dx. So now for the entire tube, for entire tube length, the total force F will be equal to integration 0 to L m by L omega square x dx. So we can say our F is equal to m by L omega square, and this we get as x square divided by 2 and 0 to L, so which will equal to m divided by L omega square, and this will be equal to L square. L and L cancels out, no sorry, square cancels out, so we get force will be equal to and 2 1 by 2 m omega square L. So in both the cases the answer will be coming as same. You can see this is the force exerted, and from the option available you can say the option number A is the correct option. Option A is correct. This completes the question. Thank you.